A-10 Warthog has served the United States Air Force for decades, and despite numerous expectations of its impending retirement, the U.S. has gone above and beyond to not only preserve it, but to make it even better. Today, we're diving deep into the updates and storied past of the Warthog, revealing how it's managed to shock the world time and time again. As we delve into the incredible updates and the rich history of the Super A-10 Warthog, get ready to be awed by this exceptional aircraft's journey, from its initial service to its remarkable resilience and its enduring significance. We will uncover the latest transformations and innovations that have made the A-10 Blacksnake Super Warthog even more astonishing. Join us as we explore the all-new Blacksnake Super A-10 Warthog that just shocked the world. The A-10C Thunderbolt II, affectionately known as the Warthog, has recently received upgrades that further enhance its already impressive capabilities. This legendary aircraft boasts an incredible resilience that defies conventional expectations. It is capable of flying with just one engine, one elevator, half of its tail, and half of a wing missing. Yet it remains virtually indestructible. Since its introduction in 1976, the A-10 Warthog has had a remarkable career spanning nearly 5 decades, and its retirement isn't on the horizon until at least the 2040s. This extended service is well-deserved because no other aircraft in the U.S. inventory can match its capability to provide close air support to ground troops. It was designed specifically for close air support. The Fairchild A-10 Thunderbolt II has earned its reputation as one of the most effective anti-tank aircraft in the world, largely due to its distinctive GAU-8A Avenger 30mm gun. However, earlier this year, the United States Air Force demonstrated the aircraft's remarkable anti-tank capabilities during initial testing at the Nevada Test and Training Range in February 2023. The A-10C Thunderbolt II showcased its ability to penetrate modern armored vehicles equipped with explosive reactive armor. Each test mission involved a pair of A-10Cs firing armor-piercing incendiary rounds at dummy main battle tanks with ERA. What makes these tests particularly significant is that the pilots varied their attack parameters and directions to assess the weapon's effectiveness against heavily armored targets. Through post-shot analysis of video footage and visual inspection of the targets, analysts determined that the tanks were rendered inoperable. Major Kyle Adkisson, commander of the 422nd Test and Evaluation Squadron's A-10C division, emphasized the aircraft's firepower. He explained that a typical A-10 gun employment requires 120 rounds, allowing the A-10 to engage 9 to 10 targets before exhausting its gun ammunition. A-10 formations can take on over 40 armored vehicles using 30mm ammunition, making it a formidable force on the battlefield. The A-10's 30mm GAU-8A gun, which protrudes from the aircraft's nose, boasts a rate of fire of 3,900 rounds per minute. The genesis of this powerful weapon traces back to the early 1970s, when the American Air Force requested proposals for a 30mm rapid-fire gun to be deployed with the AX Close Air Support aircraft. This led to the creation of the GAU-8, a prototype developed by General Electric. The government contract called for the development of 4 different types of ammunition for the cannon: target practice rounds, semi-armor-piercing high explosives, armor-piercing incendiaries, and high-explosive incendiaries. The recent testing also assessed the effectiveness of the AGM-65L Maverick and AGR-20E Advanced Precision Kill Weapon System against armored vehicles in addition to the 30mm cannon rounds. First Lieutenant Christopher Earle, a 59th Test and Evaluation Squadron A-10C Operations Test Analyst, emphasized the ongoing nature of these efforts. He stated that this testing has been in progress since the idea was initiated in 2020. The plan is to continue testing various types of anti-armor munitions in the Air Force's inventory against ERA-equipped vehicles, gathering more data now that the concept has materialized and proven successful. Other upgrades also include structural enhancements, such as new wings designed for 10,000 flight hours, as well as the adoption of modern digital technologies. One notable program, the A-10C Precision Engagement Program, introduced the hands-on throttle and stick or HOTAS system, allowing pilots to control the aircraft's functions without removing their hands from the control lever. Furthermore, the A-10 is transitioning to the modern digital battlefield by integrating multifunctional screens, helmet-mounted displays, and new electronic equipment, including advanced radar systems. These upgrades aim to enhance the A-10's situational awareness and targeting capabilities, making it even more effective in combat. A remarkable addition to the modernization effort is the use of helmets with integrated display systems, like the BAE Systems Visionix Scorpion display system. These helmets provide pilots with critical information and targeting data, thus improving their accuracy and effectiveness during missions. Additionally, the A-10 is set to receive a Link 16 connection, facilitating more efficient data exchange and communication. This unique aircraft is the only American fighter designed from the ground up to excel in delivering close air support, and it's not an exaggeration to say that it has saved more lives than most other aircraft, and many veterans owe their lives to this formidable machine. Its journey began amidst the backdrop of the Vietnam War in 1965, where the primary ground attack aircraft, the Douglas A-1 Skyraider, proved inadequate. It was slow, lacked firepower, and was highly vulnerable to ground fire, resulting in significant losses. This deficiency highlighted the need for a specialized attack aircraft that could provide the necessary close air support. However, in the search for a suitable replacement, various aircraft, from the F-4 Phantom to the F-111 Aardvark, the Northrop's F-5, and even the A-7D variant of the LTV A-7 Corsair II were considered, but none could fill the crucial gap. In 1966, a pivotal decision was made. The U.S. Air Force shifted its focus from trying to adapt existing aircraft to creating a dedicated aircraft for close air support. It would address the vulnerabilities of the A-1 Skyraider and the attack helicopters of that era. This marked the inception of the AX program, which would give birth to the A-10 Warthog. General John P. McConnell, the Chief of Staff of the USAF, ordered the development of the CAS aircraft. By December of the same year, the Requirements Action Directive for the AXCS, or Attack Experimental Close Air Support Aircraft, was presented to the Office of the Attack Experimental. In 1970, the U.S. Air Force refined their requirements to consider the potential threat from Soviet armored forces and the need for all-weather offensive operations. The specifications now included a 30mm rotary cannon, a top speed of 460 miles per hour, a takeoff distance of 4,000 feet, an external load capacity of 16,000 pounds, a flight radius of 285 miles, and an aircraft cost of approximately $1.4 million, equivalent to about $10 million today. The competition was fierce, with Northrop and Fairchild Republic building prototypes, the YA-9A and YA-10A, respectively. In a highly anticipated fly-off, the YA-10A convincingly exceeded the requirements and became the winner of the AX program. This $10 million production version, known as the A-10 Warthog to allies and the sound of an unending barrage of Gatling cannon rounds to enemies, would go on to protect American troops and their allies across the globe. Serial production of the Warthog commenced in February of 1976, and the first attack aircraft was accepted by the Air Force Tactical Air Command the following month. The production line operated at an accelerated pace, delivering over 715 Warthogs to the U.S. Air Force by 1984. The A-10 is notable for its exceptional low-speed and low-altitude maneuverability, thanks to its large wing area, low wing angle, and sizable ailerons. Its wing design enables it to perform short takeoffs and landings, making it suitable for use on primitive airfields close to the front lines. Moreover, the A-10 can loiter at 5,000 feet for about 2 hours, and this figure increases by an additional hour with the addition of a 600 US-gallon external fuel tank. Honeycomb leading-edge panels provide strength with minimal weight, and similar panels cover the flaps, elevators, and keel sections, demonstrating impressive damage resistance. Ailerons, located at the far ends of the wings, enhance roll control by covering nearly half of the wingspan. This design feature provides improved maneuverability, even at low speeds, and they can also act as air brakes, slowing the aircraft down when needed. With a lower cruising speed of around 340 miles per hour, the A-10 is better suited for ground attack than the high-speed fighter bombers of its time, which struggled to target smaller, slower enemy objects effectively. Over the years, the A-10 Warthog has transformed from a brute force attack aircraft of the 1970s into an intelligent yet equally formidable combat machine. It features an offense suite that can penetrate metal swiftly, a defense armor that rivals a cat's 9 lives, and an avionics suite so advanced that it can be mistaken for a Tesla product. Again, the core of the A-10's firepower is its 30 by 173mm GAU-8 Avenger autocannon, which can unleash a relentless storm of 3,900 depleted uranium armor-piercing shell rounds per minute. This incredible firepower, combined with precision aiming and the advantage of air superiority, can swiftly neutralize enemy infantry, armored personnel carriers, and tanks. The GAU-8A Avenger cannon is a marvel in its own right. This remarkable piece of machinery attains its maximum speed in just half a second, firing off an impressive 50 rounds in the very first second of operation. As it warms up, it unleashes a blistering rate of fire, reaching a staggering 65 to 70 rounds per second. What's truly striking is its accuracy, with the capability to place a remarkable 80% of its shots within a 40-foot diameter circle at an altitude of 4,000 feet. During Operation Desert Storm in 1991, the American A-10s alone accomplished incredible feats. They managed to obliterate over 900 Iraqi tanks, along with an astonishing 2,000 other combat vehicles and 1,200 artillery pieces. It's no exaggeration to say that the GAU-8A Avenger played a pivotal role in reshaping the battlefield. It is uniquely situated, slightly offset to the port side, with the barrel at the firing point aligned with the aircraft's centerline. This design integration ensures that the firepower is well distributed and optimized. The ammunition drum for this behemoth of a cannon measures 5 feet and 11.5 inches in length and boasts an impressive capacity, holding up to 1,350 rounds of 30mm ammunition. To safeguard these precious rounds from enemy fire, a clever system of armor plates of varying thicknesses was installed between the aircraft's skin and the ammunition drum. This ingenious design helps prevent incoming shells from prematurely detonating the GAU rounds. A-10 was mostly built around this cannon, however. It doesn't rely solely on its Avenger cannon. It's equipped with the AGM-65 Maverick air-to-surface missiles, which serve as the first line of defense against anti-aircraft systems aimed at the aircraft. These missiles can target and eliminate threats with electro-optical or infrared radiation from a considerable distance. During Operation Desert Storm, the Maverick's infrared camera was even used for night missions, essentially serving as a makeshift night vision system. The A-10's arsenal doesn't end there. It also includes Hydra 70 cluster bombs and rocket pods, GPS and laser-guided bombs, such as the GBU-39 paveway bombs, JDM wind-corrected munitions dispenser, and the AGM-154 joint standoff weapon glide bombs. To keep this legendary aircraft up to date, the A-10 Precision Engagement Program from 2006 to 2010 initiated comprehensive upgrades, bringing all A-10s to the A-10C standard. These upgrades introduced a new onboard computer, glass displays, cockpit controls, and 2 new 5.5-inch color displays with a moving map function, enhancing overall capabilities. In addition, the A-10 boasts a missile attack warning system, alerting the pilot to any incoming missile threats, be they friendly or enemy, within the aircraft's range. The Electronic Warfare Unit, the ALQ-184, further enhances the A-10's defensive capabilities. Approximately 6% of the aircraft is also covered in heavy armor, allowing it to withstand direct hits from high-explosive and armor-piercing projectiles. Redundant hydraulic flight systems, complemented by a mechanical backup, ensure that the A-10 can continue to function even in the face of extensive damage. To protect the A-10's vital interior components, including the cockpit and parts of its flight control systems, a lavish layer of titanium aircraft armor, affectionately called the bathtub, has been incorporated. This armor can withstand strikes from 23mm cannon fire and some indirect hits from 57mm shell fragments. The aircraft's front windscreen and canopy are also designed to resist fire, particularly small arms fire, which is the most likely threat when the A-10 descends towards the ground to engage enemy ground troops. To further safeguard against ground attacks on the aircraft's fuel system, all 4 fuel tanks are strategically located near the aircraft's center and are separated from the fuselage. This arrangement requires projectiles to first penetrate the aircraft's skin before reaching a fuel tank's outer skin. Most fuel system components are located within the fuel tanks, minimizing the risk of fuel loss due to component failure. To provide an extra layer of protection for the fuel tanks, reticulated polyurethane foam lines both the inner and outer sides of the tanks, containing debris and restricting fuel spillage in case of damage. One of the most compelling reasons for the A-10's continued service is its simplicity and ease of maintenance. It doesn't require specialized runways and can operate from austere airfields, making it highly deployable in various scenarios. Its straightforward design and robust construction guarantee its ability to withstand the rigors of combat and continue to operate, even in challenging conditions. This straightforward approach allows for efficient maintenance, even at bases with limited capacity. A standout feature is the aircraft's modular construction, which enables many of its parts to be interchangeable between the left and right sides. This applies to essential components like the engines, main landing gear, and vertical stabilizers. Moreover, the aircraft's robust landing gear, low-pressure tires, and spacious wings make it capable of taking off from short, uneven runways, even when heavily laden with ordnance. This versatility ensures that it can operate from damaged airfields, taxiways, and even straight stretches of highways in a pinch. In scenarios where runways, especially those at forward air bases, are susceptible to damage from foreign objects, the A-10's unique engine arrangement provides a solution. The TF-34 GE100 turbofan engines from General Electric are strategically placed to reduce the risk of foreign object ingestion. This not only enhances engine safety, but also permits the aircraft to remain operational during maintenance and rearmament, carried out by ground crews. This efficiency significantly reduces turnaround time. The design of the A-10 extends to its engine placement and exhaust nozzles, which serve multiple purposes. The engines are set in a way that directs exhaust over the tail, reducing the chances of detection by infrared homing surface-to-air missiles. Furthermore, the engine's exhaust nozzles are angled to counteract the nose-down pitching moment that would naturally occur due to their mounting above the aircraft's center of gravity. This negates the need for excessive adjustments to control surfaces, ensuring stable flight. The A-10 Warthog's enduring popularity among military pilots and its iconic status has since been rooted in its exceptional performance in real-world combat situations. Perhaps one of its most renowned deployments was during Operation Desert Storm in 1991, in the Persian Gulf. The Warthog played a pivotal role in this conflict, alongside formidable aircraft like the F-15 and the F-117 stealth strike aircraft. During Operation Desert Storm, the A-10 showcased its unparalleled effectiveness in the close air support role. Its capability to operate at low altitudes, evade enemy attacks, and deliver precise firepower made it a hero on the battlefield. The A-10 played a crucial role in neutralizing threats posed by Iraqi tanks, armored vehicles, artillery pieces, and even small targets. Its remarkable performance resulted in the destruction of over 1,000 Iraqi tanks, around 2,000 armored vehicles, 1,200 artillery pieces, and 2 helicopters. Astonishingly, despite facing substantial enemy fire, only 7 A-10s were shot down, and around 15 were damaged during the entire campaign. Operation Iraqi Freedom in 2003 further solidified the A-10's reputation for resilience and effectiveness in an aerial battle over Baghdad. One A-10 sustained severe damage, including hydraulic system failure, engine damage, and extensive damage to its fuselage, wings, and tail. Despite these dire circumstances, the pilot managed to bring the damaged aircraft back to an airfield in southern Iraq. This remarkable feat underscored the A-10's survivability and its ability to endure and return from even the most challenging combat situations. Recently, as Ukraine faced the need for airbase support to repel Russia's invasion, the A-10 Warthog once again emerged as a lifeline. This is a role it has played time and time again, a testament to its unwavering reliability. General James Holmes, the Deputy Chief of Staff for Strategic Plans and Requirements, highlights the importance of finding the sweet spot between the available aircraft and the ideal A-10 replacement. Factors like cost and affordability play a significant role in this decision-making process. The challenge lies in ensuring that the new platform preserves the A-10's unique capabilities and serves as a dependable guardian for troops on the ground, just as the A-10 Warthog has done for decades. While the F-35 was initially considered a potential successor to the A-10, there is a growing consensus that the aircraft's distinct capabilities and mission profile need to be upheld. It's not merely about having an aircraft that can fulfill close air support missions. It's about having an aircraft that excels in this role and serves as a dependable guardian for troops on the ground. The A-10 Warthog, with its indomitable spirit and battlefield prowess, remains a symbol of unwavering support for the soldiers on the front lines. As the Air Force navigates the complex path of A-10 replacement, it seeks to ensure that this legacy lives on, providing troops with the effective close air support they deserve for years to come. Thanks for watching. While you're still here, click on the link appearing on your screen to watch another of our interesting videos. See you there.